Alright, so this lesson is something that applies to all programming languages, not only C. In the last lesson, I explained to you about signed and unsigned numbers. And in that lesson, I explained that the more bits that you have available for storing a value, the greater the value you can store. So for example, if you have 3 bits, you can't store any value greater than 7. If you have 4 bits, you can't store any value greater than 15, and so on. So let's talk about what happens when you have a set number of bits available for storage and you start counting. Alright, so let's imagine we have 3 bits. We start at 0, then we add 1. Now we have 1, now we add another 1. We have 2. We add another 1, and now we have 3. Now take a look at what happens now. If all of the columns are full on the right, and you have to add 1, what happens to the columns that are full on the right? The answer is they're going to become 0 on the very next addition. So we're going to go 1, 0, 0, which makes 4. Now, what I want you to see here is that if we were using only 2 bits and we start counting like this, once we get to 3 and we have filled up all possibilities of those 2 bits, the very next number we add is going to set those 2 bits to 0. In other words, once you have filled up all of the bits you have available with 1s, so that if you're using 2 bits, it's 1, 1. If you're using 3 bits, it's 1, 1, 1. If you're using 4 bits, it's 1, 1, 1, 1, and so on. The very next number is going to set those 1s to 0s. So when we have 3 and we add 1, we now absolutely must have an extra column on the left, because that column is going to become a 1, and the columns that used to be 1s are going to become 0s. Alright, so let's imagine that we have 3 bits available for storage and we start counting. So we start at 0 and we work our way to 7. Now at this point, we have used every single possibility for those 3 bits. So if we have all 3 bits filled and we add 1, the answer is 8. But if we are forced to stay within 3 bits because that is all we've allocated to store this number, then what we will actually see for our answer is this. We will see 0, 0, 0. So in other words, if you're limited to only 3 bits and you say 1, 1, 1 plus 1, the answer you're going to get is 0, 0, 0, because this 1 that we need in order to make the answer 8 can't fit within 3 bits. So it will not be in the final answer. So I want to make sure you understand this. Anytime you have a set number of bits, you're limited to how big of a number you can store there. If you try to store a number bigger than what will fit, you'll only get the rightmost part of that answer that does fit. So if your answer is 8 and you're limited to 3 bits, you're going to get just 0, 0, 0 as your answer. So if you are limited to 3 bits of storage and you start counting from, let's say, 6, then you would have 6, add 1, now you have 7, now you add 1, and now you don't have 8 because 8 won't fit. 8 is 1, 0, 0, 0, and we're limited to 3 bits. So because you can't fit the 1, you go back to 0, and then you add 1 and you reach 1, and so on. So basically, you count to 7, then you go back to 0, count to 7 again, back to 0, and that's because you can't store any greater number than what will fit inside of 3 bits. So if you apply that same concept to 4 bits, then you would count to 15 and then go back to 0, and so on. So every time you pass the highest possible number, you will go back to 0. Now this can create a problem because you might have a situation in your program where you are adding together two valid numbers and you get the wrong answer. So for example, let's suppose we are limited to storing numbers in 3 bits and we try to add 4 and 6. Now notice that 4 can fit in 3 bits just fine and 6 can fit in 3 bits just fine. Both of those numbers have no problem fitting inside of 3 bits, but the answer, which is 10, requires 4 bits. So if you had a program and you asked that program to add 4 and 6 and you're limited to only 3 bits of storage, the result you would get would actually be 2, which is wrong. Alright, so what I've been describing is something called numeric overflow. Numeric overflow happens whenever you have a number or a value that is too large to be stored in the number of bits that you have allocated for storage. Now, this can happen very easily when you start working with large numbers and you don't allocate enough space for those large numbers. And when that happens, you can have a situation where you perform a mathematical operation on a number and you get the wrong answer simply because the right answer won't fit. Now there are a lot of ways to handle this situation, and we'll go over that later, but right now I want you to understand what an overflow is so that you can be prepared for it later.